Greetings to you all. My name is Dr. Nkateko Mabunda. I'm continuing with you the lessons on photovoltaic. Today we're going to touch on practicals, designing an indicator. That's our topic. We're going to use an LED as our indicator. If we look at our rough sketch there's an LED and it's connected to the battery, 12 volts. We have wiring. For us to limit the current to a desired amount, we need to know the rating of an LED. That was given as 20 milliamps. Milli means 1/1000. So wherever you see this, you divide by 1000. The resistor must be connected to limit a current, to provide that. But 20 milliamps, if you work on it, it's going to be working on the edge. Let's reduce it to 80% of the rated, and we use that. So here is their solution. They've used Ohm's law. If you remember Ohm's law, where you have voltage on top, at the bottom we have R and I. So to get any of the two at the bottom, you divide the opposite onto the top one. So if in this case we want R, we're going to divide the opposite, which is that, onto that. So that's basically what they do, their current, but they've taken 80% onto consideration by saying 0.8, and they also took 2 volts that is supposed to occur here and into consideration. Now let's do our own calculations ourselves and put a circuit onto test. We can't build a physical circuit before we test it using software tools. We are in the world of apps. So for most of the things which we want to do, we've got apps. Let's go for calculations. First one, we'll look at the normal calculator. We open a normal calculator. Now 20 milliamps, and we make it 80%. So there's 1, 2, and we're gonna use, so we punch it 20 milli, divide by 1000 for milli, and then equals to, and 80%. So there is our current. We're rating it at 80%. Now, what about the voltage? The voltage, we are told that from 12 volts you lose 2 volts across the LED. The remainder will be 10. Okay, now we can use another 2 that will provide us with Ohm's law, which is that. We pick up Ohm's law and we enter the voltage. The remaining is 10. The other one, if you remember there, for I, we need 0.016. The value of our resistance is calculated, as you can see, 625. There it is, 625. There are standard resistor values which we have to pick up from. You can Google that. Amongst them, you have the 6/8 series. So 680 is the closest to 625. The other one is the 560 series, 56 series, but this one, it will create higher current. So we'll go above 16 milliamps. We risk to blow. So we rather go higher. We take the 681. Let's now simulate the circuit and then check how it operates. Proto, that's what we use. And let's open up Proto. We want a blank sheet. So there it is, a blank one. Now we're gonna start placing values. You click on our blank sheet. We're gonna click on add. What are we adding? We'll start with a power source, a DC power source. I can see somewhere there. Here it is. That's what we're gonna add. It's added, and now we're gonna add a switch. Search for switch there. There we go. It's added. We move it. Select. We move, and we have to rotate it. We use that button to rotate so that it lies horizontally. Rotate, click to the end where we want to wire. It's too long, delete. Okay, we're gonna do this. It's obscure. There are rules. The lines is either they run vertically or horizontal, not diagonally. We don't do diagonal wires. We wire that one, and we wire the switch, and we wire the rest of the circuit. Now we have to set values. First, we will start with an LED. To set its value, you go where there are switches there, where you select, and the maximum output current, that's what we are interested in, supposed to be 20. If you put more, even in a simulating environment, it's gonna blow. You have to go repair. So if it's difficult to do, just type values there. 120, 20. That's it. We set the value to 20 milliamps, and the resistor we change as well. The resistance will be 625, not 625, 680. That's what we calculated and get 625, but we are using 680 as the closest to highest to the series. So that's it. With everything there, you start the simulation using this play button, right? Okay, that one must be changed to 12 volt. And now the volt drop of an LED we didn't change that. Forward voltage is supposed to be 2. We're using 2, that's fine. We must switch on right there. There is a current that flows 15 milliamps, close enough to what we predicted. And the switch is on. If we switch off, no current flows. So that's it. That's how we do the circuit. Good luck with the other circuit. We're going to continue with these practicals in our next session. And goodbye.